I'm going to quickly go over a review of topic 4 because we already did it last time. But remember, topic 4 is for loops, while loops, and if statements is what we're really testing you on. We presented if statements in the previous topic, but we've been working on not only understanding the mechanics of for and while loops, which I definitely think you all have at this point, but also being able to use them to solve problems and put into algorithms. So you need to make sure that you have both of these labs done by next week. They're both due, the for loop and the while loop that you're going to be doing. Remember that because there's 2 of them due, it's going to be even more difficult for us to sign them off, so you really want to have them done when you come into lab. If you're starting them in lab, you probably won't get them signed off. And there's a quiz on that material as well. So if you need any help, please stop by and see me or go into the help sessions. There was some question about the while loop problem. The algorithm that you're supposed to write for the root finding algorithm is literally to randomly guess numbers until you guess the right root. That is the algorithm. So there's a million different root finding algorithms that are 100 times better than that one, but this is the simplest root finding algorithm, which is to guess a number, see if it's a root, and continue to do that until you guess the right root. So that's why I said it has to be an integer root. Otherwise, that might take a long time. You could try it with a non-integer root and have some accuracy as well. All right, and then we've also been working on if statements, so make sure that you're comfortable with if, else if, and else statements as well. So one thing I wanted to remind you this time before you take your quiz in lab is make sure you're ready to use for loops, while loops, and if statements for the quiz. But I will not be asking you to write an algorithm that you already wrote on the quiz, and I will never do that on a quiz. I will be asking you to write something different, that's similar, that is of similar difficulty within the time that we have. So I'm not going to have you write a max function. I'm not going to have you write an algorithm that randomly guesses the correct root, okay? So it's going to be something similar but applied in a different way. So I just want you to have that expectation coming in. The same goes for the exam. So I wanted to give you an update on the algorithms that we've gotten to. So I've been posting these slides so you can go and check. I'm going to keep updating you with our algorithms that we've completed. But in last week in lecture and in your first lab, you've done a find algorithm. You've also done a max algorithm. And then a guess and check is the second part of your lab. Today we're going to do a sorting algorithm. And then I've also done we've done the counter several times. And in the bonus video, I showed you an algorithm that removes data. So the midterm is next Thursday, and I just wanted to remind you of the rules. I will see you before your midterm. I'll see you next Thursday, and I'll see you in lab. But just so that you can adequately prepare over the next week, I wanted to make sure I give you enough heads up. Just a reminder that the midterm exam is all handwritten. There's no computers and no electronic devices at all. The only thing you can have with you during the exam is a pencil and your toolbox cards up until topic 5. So you'll have 5 of them. The format is that there will be a portion of short answer knowledge questions. These questions are asking you to simply be able to show me that you have knowledge on MATLAB syntax and the MATLAB environment. Then there's 2 sections, reading code and debugging code, which will test your comprehension on the material. So here I will have you read through a section of code very similar to how we do it on the clickers, and you'll have to be able to tell what the code does or say what value something has in the code. I'm going to give you common bugs that you should have seen or that I've highlighted in these slides every week, and have you find what the bug is with the MATLAB error. The last section of the exam, which is the biggest section of the exam, is to write out an algorithm in MATLAB syntax. And that's going to be at least 40% of the exam. So what I've done for you guys is I've posted a review sheet with not only summarizing the topics for the first 5 topics, but I have sample questions for all of these sections so you can see what they'll look like and what they're going to be like. And I recommend that you just go through the questions in the same kind of environment that you would be taking the exam to see if you're prepared. What I've done is, especially for this write code section, is I've not only given you 2 sample questions for that, but I've also given you 3 additional ones, so that if it's something that you feel that would be that you need extra practice in, I've given you a bunch of different ways that you can practice it. The complexity is taken into account. These algorithms can take a long time to write, so I'm only going to give you things that I think that you'll have time. I usually try to target people being able to finish the exam in 1 hour, but that means that a lot of people will take the full time, but that people will be able to finish in 1 hour, if that makes sense. Usually I take the exam and write it out, but it's a really bad measure because it usually doesn't translate to how long it would take anyone else to do it. But I've been giving these tests for years and years and years, so I really know how long it takes people to take these tests. So that's not really, you shouldn't be worried about that at all. Do you guys have any questions about anything I just mentioned?
Are the quizzes, these clicker quizzes, posted on D2L?
No, they're not. They're not posted. But if you want to step by, I can show you anything that you want to see that we've done. Any other questions? So on the review sheet, there's a lot more information on there than what I'm covering, so just check it out. I'll post solutions to all the review sheet problems on Wednesday before the exam, and then in the help session on Sunday, I'm going to have Seth go through the review sheet. I'm going to reserve a bigger room so that everyone can come if you want to go through some of the answers. But I really recommend the best way of studying is to do the questions on your own, and then just check your answers after you do them on your own. We'll also be checking your binders at the exam, so just bring your binders. They should, you'll just drop them off at the door, and I'll have the TAs look through them to give you some credit for all of your work you're putting into those. Any questions? Okay, so we're going to be talking about functions, and it's a really nice it's a really nice topic because it makes a lot of things easier to start writing things out in user-defined functions. All right, so we've actually been using MATLAB functions throughout the semester already. So it's something that we just kind of threw you into so that you could start using MATLAB without actually talking a lot about what a function is. And so now we're going to start understanding more about how a function is structured. So every function that you've used in MATLAB, like the max function or the min function, is actually just a MATLAB script file or an M file that was written by MathWorks. And what defines it as something different than a script file is that a function file allows you to input information into the M file and take information out of the M file. So we're going to be talking about how that's structured, and we'll talk about some of the intrinsic functions that you've used, and then we'll end with how you write your own. The nice thing about MATLAB is that it's getting less like this, but it's almost like a open source code in a lot of ways, in that anything that's written in MATLAB, you can actually go find that file and edit it yourself and maybe save it as a different file and use it. It's harder to find those now. It used to be that if you used the max function, for example, and you called the max function and you called it incorrectly, it would actually link you to that file, and you could click and it would open up the max.m file, and you could see a little the whole script and what it is that it's looking for. And then you could even save it as mymax and change it to however you wanted to use it. They've kind of put up more of a wall around that it's harder to find those, but that's the way that it was originally intended, so that users could create their own M files, but also use common scripts that they would need. And so it's all defined with this function declaration line, which is the first line of the script file. And the first thing is the word function. So if you've ever opened up a pre-existing function, perhaps you've Googled things and looked for how to do things. If that first word, the first word in the first line of code is function, then that means that that file is a function file. Then next to that, you have your outputs in square brackets. You can have as many outputs as you would like, and they are separated by commas. Each variable indicates a different output, but the variables can hold full arrays of data. They don't need to be single scalar values. There's an equal sign after the square brackets, and then you have your function name. And then in parentheses behind your function name is your inputs. So does this look familiar to you all when you call some of the MATLAB files that you've been using, that there's this notation of inputs in parentheses behind the function name and outputs in square brackets on the left-hand side of the function name? It should look familiar. Does it look familiar? I'm using like the max function, the find function. And a couple notes about this. The function name should be the same as the file name. And if it's not, the file name is used, not the function name. So if I saved this as Shannon example, or if I wrote Shannon example as my function name, but then I saved my file name as Shannon, if I tried to call Shannon example in the MATLAB command window, it wouldn't know what it was. It would only know what Shannon is, and I'll show you that once we open up MATLAB. So underneath here, you should just have maybe a comment explaining what your function does. So especially since your function now is requiring inputs and outputs, there should always be a description of what's expected. And then the rest of the file is just going to include any commands that need to be executed, and then you close the function with an end, just like you close your for, while, and if statements. So I want you to just jot down a couple key things about functions. The first thing is that your outputs have to be in square brackets and separated by commas, and that there can be as many as you want or 0. So you could totally get rid of this and have no outputs, and it's still a function because you have this function here. Your inputs are in parentheses behind the function name. There also can be 0, 1, or many inputs. There's no rule for that. So you can actually write a function that has no inputs and no outputs. So why would you ever do that, or what would be the point of that? So I'm going to scroll over to MATLAB and just open up an M file that I wrote for you. Remember this one? So here, I wrote this one a couple lectures ago, and it's just a regular script file. So if I run this script file, oh, this is that guess one. It executes, and it works just fine. And what you'll notice in the workspace is when I run that M file, everything, all the variables that were in the file, they show up in the workspace. Do you guys see them all there? I actually never write script files like this. I actually always write function files. So I'm going to just create a function now where I'm going to use that function declaration line, but I don't have any inputs or any outputs. I'm just going to use the function line and as a way to define that it's a function. So I'm going to clear out my workspace, and I'm going to rerun this. So I ran it again, but what you'll notice is that in the workspace, there's no variables. It doesn't know about them. This is a really important thing when writing big codes, is that it keeps your variables contained within your functions. So that way I could reuse those variable names if I'm going to call this function in another script, and they won't get overwritten. So that's the big difference between functions and script files, is that factor. But then I could just do other things, like I can include an input. So I'm going to include an input n, and that's going to say how many times my loop is going to run. So I've just changed to have one input, and I have an n here now. So what I'm going to do is I'm going to go back, and to run this file, I used to just type test, right? That's how I ran the file before, but now you'll see it's saying there's an error because there's not enough input arguments. So when you write a function and you define that there's one input, the only way to run the function now is to give it an input. So if I want to run this, I actually have to give it a value. So with outputs, it's not the same thing. So let's say I wanted guess to be an output of this file, and I'm going to take away this input and go back to what I was doing before. So when I run test with my one output, you'll see that it doesn't have a problem with oh, I just typed F for my age. It still runs fine with no outputs defined. All that means is my output is just going to go to that ANS default if I don't give it an output, but it still runs fine. It just doesn't save the output to anything. So we'll talk about that a little bit more with some intrinsic functions, but I just wanted to show you the difference between that before I moved on. You guys have any questions about any of that? Okay. So let's just talk about some MATLAB functions that you've already used. They work exactly like these user-defined functions that I'm going to show you how to write, and that's what's kind of nice about them. So because I want you to have nice notes for this part, I'm just going to write it out. You can try it in MATLAB later. So let's say I have a vector v, and in the command window, I want to use an intrinsic function. Is it better if I just do this? I'm just going to use an intrinsic function, the max function, which we've used many times, to find which of those values is the biggest. So I'm going to put my input v into my function max. So we've all done this, and it was totally okay with us doing it this way, and it gave out an answer of 7. So you found the max of that function. If you just typed max and didn't give it an input, you'd get that same error I just showed you. So this is an example of a function with one input. Okay. So now, what we've also done with the max function is we've wanted to save the value that it gets out from the max function. So here, I'm going to plug in a v as my input, but I'm going to give the output a variable to go to. So I'm just giving it the variable mx. So when this runs, mx is going to have a value of 7. So this is an example of running a function with one input and one output. So outputs are optional, inputs are not optional. Functions don't run if you don't give it the right inputs. And then I can also give it 2. So a lot of functions have secret additional outputs. So we use the max function, and I helped several of you with this. And there's a second output to the max function that you can get by giving it two outputs. This is something you could do by just looking at the max M file or the max help. And what you'll see is that if you give it to the M file from for the max function will give max the max value and end the location of the max value. Oh yeah. So this is an example of a function with one input and two outputs. And that's how outputs work. If you don't ask for the second output, it's not going to show you what it is, even in your own user-defined outputs. So the only output that's automatically printed to the screen is the first one. So with the max function, you always see the max value. But there's other outputs programmed in, but you only get them if you try. We've also used functions that have multiple inputs. So one example is the input function. I know that's confusing because the name is the input function, but the input prompt function that we've used. If you remember, we have used this several times to prompt the user for a response, and we saw how you can put in two inputs. One is the question that you're going to ask, or the command you're going to print to the screen. And the second one was an optional input that allows you to indicate the type of variable that you're asking for. So this one is a function with two inputs. And I'm just showing you ones that I know you've used because we've done them in quizzes, but you have certainly used many others in your own files, but everyone's kind of using their own thing. Yeah. Can you say it a little bit louder? For this max function, yeah. So these are already written functions, so you'd have to look up what the outputs are for them. For the max function, the first output is the value, and the second output is the index of where that value is located. But every function is written differently. Yes, you can use any variable. I could have chosen anything here. I could have just chosen A and B. Yeah. It's just giving it that place to go gives you it. It doesn't matter what variable you use. So what we're going to do for the rest of the time is talk about any other questions before I move on. Okay, we're going to talk about user-defined functions. So I have a simple example that I'm going to do, and then I'm hopefully going to get through a sorting example as well. So I thought this would be a nice one to do, this first simple one, because this simple example is something you can actually use for your root finder if you want to. It doesn't make things like drastically better, but it's kind of fun. So first, if you've ever noticed, if you click on the new thing, you can either click script or function. So script will just give you a blank file, and then function actually fills in with the declaration line. So you can always start with this if you want to. You have to fill everything in, so I'm going to first I'm going to create a function name. So I'm going to be defining the function that you are using for Lab 4 right now. So your Lab 4 is solving the root of this equation here. So this code that I'm writing is just going to, given an x, define the f from this function. So I'm going to name this function define f. And then I need to fill in the variables I would like to use for my inputs and my outputs. So I'm going to use x here and f here. So what this will do is to run this, if the user gives me an x, I'm going to tell you the f associated with that x for this function. So I'm just going to write out in MATLAB syntax the function here, and I'm going to allow for full arrays of x's to come in and define full f's as well. So then when I save this file, I'm going to make sure and I use the same name. If you don't do anything, it will automatically give you that name. Do you see how it says define f, which is what I chose as my function name? So you just want to use that function name. You'll notice that now it will no longer allow you to just click run. It does give you a error message of why it's not running, but you'll see if you just click run with functions that it won't work because there's no inputs. So you can actually use this and put in your input here, but I find that really clunky because you have to retype it every time. So what I prefer to do is just put in my input in parentheses in the command window. So what I just did is I put in 1 as my x, and that equals an f of 1. That's just a coincidence. Does anyone know what the roots of this equation are? Anyone remember? 2. So we should get 0, right? Oops. Is this the right function? Oh, great. That makes sense. Yeah, I want my output to be f. So 2 is a root. 2 is a root? Negative 2 is a root. Okay, let's try negative 2. Like that. You'll see we'll get the root out as 0. So instead of writing this equation explicitly, you could write it in a function and call the function. So for example, in your script file that you're writing right now, you have a while loop that's running for some amount of time. This is not what you're doing, but I'm just going to get it set up so that it can run so we can see it. So let's say I just want to plug in a bunch of different values, maybe all the way up to 20. So I can just call my function define f inside this m file and plug in different values. And it can just, instead of putting in that function directly, oops, I've already used that. You can call that function I just wrote inside another function. So right now this is just another script file, so if I run it, you'll see that it's just going to plug in all these different values that I had it plugged in my loop. But I'm not even giving it an output or anything, but it just shows you that you can define a function and then call it within another function or within another script file, which is really the strength of these function files. Do you guys have any questions about this one? About this define f simple one? Okay, so the last one I want to do, and I'm not actually going to go through all the steps like I did in the past. I'll do that next week when I do some examples, but this one I'm just going to define for you. Yeah, question?
So we haven't done the second part of our lab yet. Can we use a function?
Yeah, you can use a function. There's no outputs or inputs though. Right? There's no, you can do a function, but there's no outputs or inputs for that lab assignment that you're doing. But yeah, you can use functions for everything if you want to. They completely replace output files. Okay, so this is what we're going to do for this one. We're going to write a sorting algorithm, and a sorting algorithm just is going to read in any array and sort it from increasing to decreasing order. So for this example that I have here, the output, is there like, you guys have any questions, or is this making sense? You guys following? Okay, so I'm gonna just go through the logic of a sorting algorithm. So you guys should have already written the max function if you're kind of up to speed with your assignments. So this is like one step more complicated than a max function. So I'm going to read in a variable that's holding an array of numbers, and I'm going to sort them from decreasing to increasing order. Okay? So the first step of writing a sorting algorithm is to find the smallest number in the array, right? So that's like a min function. So this is how I write my sorting algorithms, but there's actually quite a few options. There's swapping, there's different comparing algorithms. What I'm going to do is find the minimum value, and then I'm going to repeat finding the minimum value as many times as it takes in order to get through all of the values. So I've created the declaration line, my sort, and then I'm going to create an input x, which is the unsorted array, and the output y, which is going to be my sorted array. So my x is going to have whatever was inputted into the function. So an example, think that the given array is some array of 5 numbers v. So what we want to do is be able to find the minimum. So I think a lot of you have actually already, I saw a lot of you do this on the quiz already because you were already working on your max function. But hold min will hold the minimum value that I'm looking for that's temporary. So I'm going to start it out as infinity, which means that anytime a value is smaller than that value, I'm going to replace that value with the actual minimum. So what I'm going to do is create a nested if statement that will go through and check each one. So if I start hold min at infinity and I check, is hold min less than the first element? No, this first element is less than infinity. So this is actually my new hold min. So I'm going to replace hold min with 0, the first element of the array. And then I'm going to go to the next value. Now remember, hold min is now going to be 0. So is 0 less than 4? Yes, it's already less than 4, so I don't want to replace this value. So I'm going to write an algorithm that's able to do that with a nested if statement inside a for loop. So my if statement condition is I'm going to check if the value of the array, and remember my array is x in this case, it's my inputted unsorted array. If it's less than hold min, then I want to replace hold min with that value. Does that make sense? And I'm going to do this for all the values in the X array. Oh, thanks. So this itself is just a minimum function. So if I just stick with this, all I should get out of this algorithm is the minimum of whatever I input into it. So I'm going to save my sort, and I'm going to run it in my command window and see what I get from just what I have so far. So I'm going to plug in. I think I have an extra end. I'm going to plug in my array that I had put in the comments, and it's finding that the minimum is -5. So all this is doing is it's starting out by giving hold min a value that's definitely not going to be smaller than any of the values in the array. And then it's going to go through each element of the array, and if the element is smaller than hold min, it's going to replace hold min with that value. And it's going to do that for each element. So this is a minimum function, and this is exactly what you need to do, but you need to write a maximum function for your lab. So if you haven't got there, this should be helpful. Then the second thing you need to do is do this as many times as you have elements. So I'm going to create another loop around this. And this loop is going to run every time, and every time it finds a minimum value, I'm going to put that minimum value in a new array y, which is the sorted value. Okay, so all I did is I created another loop j, and it's going to define a new variable y and put that minimum value in each element of j. So when j equals 1, it will find the minimum of x, and it will put that minimum in the first element of y. So let's see what this looks like when I run it just as is. So what do we see is happening? So it found the minimum 5 times, but the minimum was always -5. So in order for it to actually sort it, what do we have to add to this algorithm to get it to find a new minimum, not the one that it just found? Yes, you have to remove the previous one. So to do that, all you're going to do is take and remove the previous value using those square brackets. And what I usually do is just create another index I called hold in inside that if statement that will keep track of what index that minimum was at as well. Do you guys think this will work? Should we try it?
What does the IL do?
It should be I semicolon. Thanks. Okay, so now we're removing the value as well. So now it's sorted it, right? And that's a sorting algorithm. It's easy to see me do it, but it's a lot harder to figure this logic out on yourself. So sorting algorithm is pretty complex. So for your assignment, you're just going to need to do a maximum, which is 1 step less complicated. And then hopefully now you can start working on lab 5 where you're going to start writing functions, which is going to allow you to input and output things into your script file. You have a question? This here, what does it do? That removes the value. Open and close square bracket removes that value from the array. I can show you. You see it?
Question on that. So the whole command D.
Yeah.
So you just replaced. You know you had a set of -5s.
Yeah.
So what did that do?
So basically it was finding the minimum value of the same array every time. But what I actually wanted to do is I wanted to find the minimum value except for the one it already found. So if it finds -5, I want to take that value out and find the next one without including that one. So I want to remove that yeah.
So then it sorts it from least to greatest.
Yeah. Yeah.
Wow, that's weird.
Yeah, if you take another look at it, time to digest it, because it's a really not that straightforward to just get on your first thought. You know what I mean?
Yeah.